Today we will see the physics behind catching the train. Before the newly invented railways began connecting major towns and cities in the 19th century, each place might have its own standard time determined by a clock on the town hall. It wouldn't matter if two places several miles apart were on slightly different times. Most people did not have watches, and they organized their day around sunrise and sunset. The introduction of the railway timetable changed all that and meant that a wider standard time became necessary. Trains were able to distribute the official time as they went, and the whole concept of punctuality took on a modern meaning, or happy days. The standard unit of time is the second, initially based on the spin of the earth. 1 second was 1 by 86,400th of a day. The more scientific modern definition is a lot more precise and reliable, but hardly easy to remember. So it is officially the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. If you want to be on time for a train today, though you won't have to worry about that because your wristwatch may be adorned with an inexpensive but impressively accurate quartz watch. This marvel of microelectronics and engineering has made us all take super accurate timekeeping for granted, where once it was the preserve of the rich. Let us look into the chronometry on the cheap. Watch enthusiastic reckon that a modern certified mechanical chronometer, yes, it's a fancy name for a fancy watch, will be accurate to about 3 seconds per day. However, a cheap modern quartz watch may be accurate to 1 second per day for just 1/1000th of the cost. So how does a quartz watch keep such good time so inexpensively? The timekeeping is down to the piezoelectric effect, a remarkable property of crystals and some other substances. When these are squeezed or otherwise manipulated, they generate a small voltage. What's even more useful is that the process works both ways, and the piezoelectrics crystals respond to electrical stimulation by vibrating. Quartz timepieces are regulated by the piezoelectric oscillation in a quartz crystal. The crystal is tiny, just a few millimeters long and shaped like a tuning fork because this allows it to vibrate steadily. A small voltage from a battery stimulates the crystal, making it vibrate exactly 32,768 times per second. Here's the reality clever bit. It is vibrating because of the piezoelectric effect. And the piezoelectric effect means those vibrations generate electricity. Regular DC, that is direct current, electricity goes in and precise electric beat comes out. The rest is simply a matter of counting the oscillations and displaying the result in digital or analog form. That is easy and cheap for mass produced microelectronics. Let us also look into piezoelectricity. The piezoelectric effect is so useful that large part of modern life has come to depend on it. One early application was in sonar system to detect submarines using a piezo transducer to produce ultrasound waves and detect any echo. Probably the best known application is in the spark generator on gas stoves and barbecues, where a simple push makes a spark strong enough to cause ignition. The property has also found use in record players, microphones, and scientific instruments such as electron microscopes. There have been attempts to use piezoelectric effect to harvest energy from everyday activity. Even your shoes can become portable generator to recharge your phone while you walk or run if you are late for the train. Hope you have learned something from this short video, and if you have liked it, press the like button, and if you have not liked it, you can press the dislike button too. If you have not subscribed my channel, kindly subscribe it. And this I am dedicating it to my physics teachers from a non-physics teacher. Have a wonderful learning ahead. See you in my next video.